an amount of ice of mass 10 to the power minus 3 kg and temperature minus 10 degrees centigrade is transformed to vapor of temperature 110 degrees centigrade by applying heat. The total amount of work required for this conversion is. So initially we have a ice of mass 10 to the power minus 3 kg at temperature minus 10 degrees centigrade. Now it is transferred to vapor of temperature 110 degrees centigrade by applying heat. I have to calculate the total work required. So initially it is at minus 10 degrees centigrade ice. Now the temperature, so the first temperature will rise to 0 degree centigrade and it becomes 0 degree centigrade ice, and then it will become at 0 degree centigrade water. Then the 0 degree centigrade water when heated will reach at 100 degree centigrade water, and then 100 degree centigrade water will change its form into vapor at 100 degree centigrade, and the 100 degree centigrade at when heated again it will reach 110 degree centigrade. So we have to calculate all these values of required heat. So say the first one, that is Q1. Let's say the heat required for the ice to reach 0 degree centigrade. We know that Q is equal to mass into specific heat into change in temperature, that is ms into delta T. So here mass is the 10 to the power minus 3 kg. S, that is specific heat of ice. So specific heat of ice is given 2100 joule per kg Kelvin, 2100 into change in temperature, that is minus 10 to 0, minus 10 to 0. So the change in temperature is 10. So this becomes 21. So this becomes 21 joule. Now calculate the heat Q2, that is when the ice at 0 degree centigrade becomes water at 0 degree centigrade. So the state of the object changes, that is here we have to take into consideration the latent heat of, so that we have to calculate take into account the latent heat of ice, that is m into delta L. So required heat is m into delta L. M is 10 to the power minus 3 and latent heat of ice is given 3.35 into 10 to the power 5, 3.35 into 10 to the power 5. So 10 to the power minus 3 into 10 to the power 5, that is 10 square. So 3.335 joule, 335 joule. So now it reaches at a point at stage 2, that is it becomes water at 0 degree centigrade. Now the water at 0 degree centigrade when heated will become, we reach 100 degree centigrade water. Let's say this is Q3. So again Q3 is mass into specific heat of water into change in temperature. So mass is 10 to the power minus 3. Now the specific heat of water is 4180 joule per kg Kelvin. So 4180 into temperature change, that is 0 to 100 degree centigrade. So temperature change is 100. So this again becomes 418 joule. Now it reaches a point at 100 degree centigrade water. Now the 100 degree, now if we again give heat, the 100 degree the water at 100 degree centigrade becomes the vapor at 100 degree centigrade. So the state of the object changes, that is here again we have to take the latent heat of, consider the latent heat of steam, that is m into delta L, that is latent heat of steam. So here mass is 10 to the power minus 3 into latent heat is that 2.25 into 10 to the power 6 joule per kg, 2.25 into 10 to the power 6, that is 10 to the power minus 3 into 6 is 10 cube. So 2250 joule. So now it reaches at this stage, that is it becomes vapor at 100 degrees centigrade. Now if we again heat to 110 degrees centigrade, then the heat required will be m mass into specific heat of vapor into change in temperature delta T. So mass is 10 to the power minus 3, specific heat of steam is 1920 into delta T, that is change in temperature, that is 100 to 110, that is 10. So this again becomes 19.2 joule. So the total heat required or the amount of work done is equal to Q1 plus Q2 plus Q3 plus Q4 plus Q5. If we add all these values, that is 21, 335, 418, 2250, 19.2, it becomes 3043.2 joule. So 3043, that is the answer. So here option 2 is the correct answer. That is the total amount of work required for this conversion is 3043 joule. Thanks for watching. Please like this video, subscribe my channel and share this video.